So our next presenter is Helin. He's software engineering manager at Intel. Helin obtained his master's degree of engineering in 2004 and has more than 12 years of experience of software development on DPDK, Linux, smartphone, VoIP, and now is the maintainer of I40E on DPDK community.
Hello everyone, and to try to introduce the topic of migrating from 10 gig to 25 gig Ethernet. By the way, I'm from China. This is the agenda today. Tell a little bit about why 25 gig Ethernet is coming, and the Intel Ethernet controller and connection list, the whole product list, and the 25 gig NIC XXV710 key hardware features and the key DPDK features, and the details of why we need to migrating from 10 gig to 25 gig. And the last thing is everybody are interested in the performance, 25 gig performance. Yeah. Here's why 25 gig is coming, which is not the plan early, 10 gig to 40 gig and then to 100 gig. Now 25 gig has been the standard after 10 gig NIC. It's driven by the data center, not by the technical comms area. So it's easy to upgrade from 10 gig to 25 gig. And it can be better utilizing the PCI bandwidth, because most of the time the product will provide PCIe Gen 3 with 8 lanes, which is very close to 50 gig throughput. For 25 gig, maybe 2 ports, then just the 50 gig. It's better to utilize the PCI bandwidth. And the most important thing for customers is cost. It costs less because there's only one fiber channel is enough for 25 gig. Unlike 40 gig. 40 gig, it needs 4 10 gig fiber channels, which is different. We can see that a bit about why the cost is different, because the lane are different. For 25 gig, we just need one lane. That means one fiber channel. Here is all the Intel Ethernet controller and the connection product list. Mostly are 10 gig, but we have a new product launched early this year, 25 gig. You can also provide 10 gig interface, but this is the first 25 gig NIC from Intel. Everybody knows almost all the legacy 10 gig NICs, 82.599 and X520, X540, X550, and X557. Actually, they're all SGB driver-based NICs. In the past 1-2 years, we have added a new series which is using I40E POMO drivers. First is 10 gig, X710 is 10 gig NIC, XL710 is 40 gig NIC. Now the XXV710 is the new addition to that series, which is using I40E POMO driver as well. That means maybe it's easy for users to design a product, no matter 10 gig or 25 gig, it's the same driver. Here's some key hardware features on that 25 gig NIC. It can provide single and dual port, 10 gig or 25 gig. It's a new addition to the Intel Ethernet 100 series network adapters. Some key features, PCIe Gen 3 with 8 lanes, and it can provide the network virtualization of nodes, including VSLAN, NVGRE by default, and we can have more support VSLAN GP with NSH and MPS, and maybe more in the future. That offload can provide the packet steering and checks offload and the packet type recognition, etc. As an Intel NIC, flow director is a standard for all the Intel NIC. It provides a good enough mechanism for traffic steering. And it provides intelligent offload to enable high performance with Intel Xeon processors-based servers. It could be something about cache alignment and some advanced descriptor format for beta utilizing the vector instructions, something like that. And of course, our virtualization innovation for maximum performance in virtualized environment, NFV, SDN, cloud. The new adaptive link of 25 gig established, which can provide better interoperability with the 25 gig switch, which is most popular in the deployment of a data center and maybe more areas. Here's the key DBTK features we provided with for that NIC. First, 25 gig link speed, and we provide the same features as Intel X710, XL710 NICs. That means same features and same driver to support everything about 10 gig, 25 gig, and 40 gig. DDP is a dynamic device personalization feature, which is going to be added in all the FOD NICs, which can be used to redefine some silicon internal packet processing pipelines and to support more protocol for steering, for example, MPS and more. So it's a cloud, we call that a cloud filter, can support the traffic steering to VFQs based on VSLAN or NVGRE or maybe others. Depends on how to configure the NIC, how to provide the profile for the dynamic device personalization. DCB and QoS has been enabled for VF for NFV scenario from I40E driver, from I40E NICs. Yes, it provides excellent small packet performance for 25 gig. Here's the NIC silicon internal packet processing pipeline. The legacy NIC, as an example, 82599, it provides a fixed packet path graphic. So it can only recognize the known packet types. It cannot be changed after the silicon has shipped out. So we cannot add anything new about the packet passing, packet processing in the legacy NIC, but it's good enough as that NIC is very popular in the past for 10 gig side. For 25 gig, we can provide the configurable input set for ISS and the flow director, which means we can flexibly select the field from the packet, from the first 128 byte from the packet for hash calculation and flow director, which is very flexible. And the DDP support is ongoing. It can provide more flexibility to support more protocols. Maybe GTPU, maybe PPPoE, maybe more. It's ongoing. That feature can provide traffic steering to VFQs, checksum float, and packet recognition. And even we can provide we can provide the ability to redefine the packet type value. That means we don't, for I40 NICs, we can recognize more than 100 packet types. Maybe most of the time, users don't need such more packet types. Maybe they just care about IPv4, IPv6 only. Then we can redefine the packet types, the value, and then it's easy for the user. So 25 gig provide more flexibility for a lot of features. Internal switching. The legacy NIC is not, it does not provide the concept of which has the bridging. It's just using pool selection to provide the similar functionality on the next NIC. It uses 128 Ethernet MAC address filters shared with all the L2 filtering, and the 64 shared VLAN filters, and the mirroring by pool, not by VF or by VEB, and VLAN or link. So it's forwarding of broadcast the packet to multiple pools. So for the VM to VM switching, maybe it's not a true switching. It's just directed the packet back to the IS packet buffer to provide the similar functionality. But on 25 gig NIC, it has a VEB mode and a VEPA mode. By default, the DPTK supports the VEB mode, which means we can do bridging between different VF based on VSI. So that's easy and very convenient and very flexible to do the VF VSI switching. So it's very convenient. And it provides floating VB. Floating VB means there's no need to connect the VB to a real physical port. So it can be used to connect all the VF together, nothing about the physical port for internal VF switching. So we call that the floating VB. And the rules in VB is very flexible. It can provide MAC VLAN pair, and it can provide flexible field selection via the cloud filter. And it provides the Ethernet type filter. It's very flexible comparing to the legacy NIC. Classification. Here's a comparison between the legacy and the 25 gig NIC. For the Hashi algorithm, the legacy just support the Microsoft-defined one with 4 bytes key. On 25 gig, it provides 40 byte key. It can also provide a simple XOR Hashi calculation mechanism and a symmetric simple XOR algorithm. It's more flexible. Maybe the symmetric one is very useful. And for the hash input set, the input set means the field we selected from a received packet for hash calculation. From Nexi NIC, it can support static and 5-type only. But from the XSV710, it's quite flexible. You can select any bytes from the first 128 bytes from the received packet for hash calculation, and of course flow director, exact match. For the flexible payload, the legacy technique provides one word only, but now we can provide up to 8 words in XXV17 with 3 locations within first 480 bytes for L2 and L4. It can be defined by the users, which field and how many bits to be used for the flexible payload exact match. Flow director is similar to the ISS, but there's only exact match supported on XXV17, and more than 10 fields from the packet can be selected by using the input set feature, which is the similar thing of the ISS input set. Queue allocation. There's no VSI concept in the 82599 NIC, so all the queues are shared between all the VFs and the PFs. So the queue indexing is it's non-virtualized mode. It needs to provide several bits for the DCB or UNTC indexing. Oh, the character is a little bit small. Yeah. And for the 25 gig NIC, in total the silicon provides more than 1K Q pairs per PF, and they can provide 256 VMDQ groups per PF and 128 VFs per adapter per silicon. So there's a very clear concept of VEB, VSI, and for VF. So that's very clear. That means each VF, that means VSI actually can have its own RSS component and RETA table and their own queues. The queue has been allocated per VSI, means per VF per PF. So VF is more and more similar to PF. I mean the functionality and the behavior. The queue by default is set by the config file. We can change that flexibly. Depends on your use case and how many VFs you want to use. This is a virtualization feature comparison. They all support SRV and VF to PF mailbox on 25 gig NIC. It's called the admin queue command. The VF function are different. The number are different. 25 gig provides 128 per device, while the legacy provides 64. And the maximum number of queues are different. 25 gig provides more queues, number of queues, and the number of queues per VF has been increased comparing to the legacy 10 gig NIC. Which is very useful for hash ISS hash calculation and flow director. And the VMDQ VSI is also the number. The queue for VMDQ VSI is also increased to 16. The MAC address per device and per port. The number of MAC address can be 1K now for the XV710 NIC, And the VLAN tax also increased to half K. And how to direct the packet directly to the VF queues, while the legacy 10 Unix doesn't support that. ISS and flow director per VF. Yes, the new cards support that per VF and per PF, while the legacy 10 Unix shared between all among all the PF and VF. Switch mode, this new concept in XSV710 is VEB switching. And per music mode, per VF, per virtual machine is supported by the new card with VLAN and multicast and unicast. For the legacy one, you can just support the multicast only. Sorry, this is the last page performance. We have two scenarios tested, which is the typical performance testing on DBTK. For the first case, we are using two cards, which means we are using two PCIe Gen 3 by 8 interface for this performance testing, which may be able to provide better PCIe bandwidth and something like that. Yes, this scenario is using bidirectional packet forwarding with using L3 forwarding. Maybe we are using more cores because we are care about the NIC performance. So you can see that from 69 byte packet size, we can achieve line rate at 25 gig. And even for the smallest one, it can achieve around 96 of line rate throughput. The bottom half is we are just using one card, which means we are using only single PCIe Gen 3 by 8 interface to do the similar performance testing. For the smaller packet size, the performance is not good at the up one, but for the large packet size, it's also good, almost line rate. Yes, that's the performance. We can refer that performance update on dbtk.org. There's a section there which contains a lot of NIC and CPU core performance data there. It's publicly accessible. Okay, that's all today I have. Any questions? Or we can talk that later.
Hi. You spoke about this protocol offloading at the NIC to offload that to the cores. Is it possible to do it, or how exactly it is just specific to the IP layer protocol itself?
It's possible, but by default we just support the VSLAN and MEGI.
Means there.
It means for packet, it's something like a flow director. You can select some field in the payload, not in the header, for packet classification.
Hi, this is Swapnil here. So I have two questions. Actually, one is with respect to VXLAN, offloading. So you are means what parameters you are taking, like one or two parameters like VNI and outer MAC or outer IP. And the second question is, does Intel support PMD on NIC partitioning in power with this 25 gig?
What do you mean NIC partitioning?
Partitioning. So the PF can be converted into 8 ports, 8 physical functions, and the PMD can be installed on that.
Okay, you mean single port, multiple function per port, right?
Yeah.
Okay. For your first question, by default it cannot, but we provide a input set which can be used to flexibly select the field for steering. There's input set feature. I already told that it's ISS flow director.
Okay.
And could be used for baseline, VNI, or something like that.
So the VXLAN filtering also you do with, so flow director is one area which can be for generic packets. Just wanted to know about, particularly for filtering on, VXLAN packets. So all the parameters like outer IP, outer MAC, VNI, you are providing right now.
It can be selected.
It can be selected.
But by default, it cannot.
Yeah. Okay.
Yeah. And for the partitioning, I don't think we have support that right now. But maybe in the future,
Okay.
but not on 25 gig right now.
Okay. Thank you. Thank you.
Thank you.